Very important aspects as far as the networking is concerned. So let's go and talk about that. So that is called routing, because you have already understood in the network layer, one of the most important functionality is to route the packet to the correct destination, so as the proper delivery of the packet. Now let's try to understood how exactly this routing is going to work, so to deliver a packet to a particular destination. Look into this diagram. So if I look into this diagram is consisting of several networks. If you look into, so I can think of, just a minute. Just a minute. What is happening? Just 1 minute. Pen is not working sometimes today. Just a minute, 1 minute. Yeah. So now, if I look into here, so this is consisting of several networks. If I can think of, this is one network. So this is another network. This is another network. And this can be another network. This can be another network. Okay, that means there are several networks if I look into this diagram existing. Okay. And we already know if I want to communicate from one network to another network, router is a must. That means if you want to talk to from this network to this network, a router must be connecting both the networks. Okay, so that is what is the use of a router. But now the question is how this router is going to help us to route the packet to the correct destination. Let's try to understand. So now if I look into, let's say the IP address of this system is 192.168.1.1, and this system is 192.168.1, or let's say it will make it .2. So this is 1.3. So this is, let's say, 192.168.1.4. And each interface also, we already talked about router. Each interface will be assigned with an IP address. Let's say this interface is assigned with IP address 192.168.1.1. Okay, this is the interface assigned with the IP address of this. Okay, now my requirement is to send a packet from this machine to this machine. Okay, from host 2 to host 4. This is my requirement to send a packet to. Okay, now the question is, whenever I'm going to send a packet from here to here, so what is going to do first? First, it is going to look into the destination IP address. So now I want to send a packet from this machine whose source IP address is 192.168.1.2 and whose destination IP address is 192.168.1.4. Okay, so whenever a communication is going to happen, first of all, it is going to look into the destination IP address. What is the destination IP address? 192.168.1.4. Let's say assume it is a classful IP addressing. Can anybody tell me if it is a classful IP addressing, what is the network not required? So in that case, what happens? So the packet sent from this machine is not going to go to the router. It can be directly delivered to this particular host through this particular switch. Okay, so that is one scenario. Another scenario. Let's say now, so this machine wants to send a packet to this server. This server IP address is, let's मान के चलिए 10.1.1.1. Okay. Let my source and destination belong to different networks, and if I want to communicate, I have to make the communication via routers. Otherwise, no communication is possible. So that's why. So whenever this packet is supposed to send to this, ultimately the packet has to first send from this to the router. Once the router receives this packet, so now look into in this router, whatever I have highlighted, how many interfaces are connected in this router? How many interfaces are there in this router? In this example, important aspects we have to understood. Every router has to maintain a routing table. Every router has to maintain a routing table, and inside the routing table, it has to keep certain information that will help to deliver the packet to the correct destination. So we'll tell just now. Okay, after a few seconds. But initially, you just think of, so that means certain information has to be already available at the router That is what is called as a routing table. So by looking into the routing table, the router could able to take a decision. If I want to go here, then should I go and deliver the packet on this interface or this interface or this interface? That is, so what is going to be so done by the help. So there is a software going to run. So that is called as a routing algorithm. So that means every router and a routing algorithm has to run, so decide or to populate this particular routing table from time to time. And based on this routing table, the router can take a decision what is the correct path to follow for delivering the packet to the final destination. Getting my point, everybody? Everybody got my initial? So what is the use of, how routing works? So basically how routing works? So routing depends on the destination IP address and destination network. Okay, if it is same, so it has to be delivered directly. Like the first example I have given, it no need to consult the router to go and deliver your packet. Directly, it will go and deliver via the switch. But if the destination IP address or destination network is different from your network, so then it is going to forward to the routing table, to the router. So then to which router it is going to forward the packet to? So whenever a particular destination wants, a source machine want to send a packet to this, let's say, so this source machine wants to send a packet to this server. So then which router it is going to send the packet to?
Every router.
Always remember this concept. I have already told it earlier. So default router. So there is a concept of default router. That means, look into here. If I want to send a packet, okay, so to this network, first of all, my packet has to come to this router. Yes or no? So once it is coming to this router, so if I want to send a packet to here, so then it has to follow this path. So that means this router will decide, okay, the packet will send to this router. Then this router will decide, so the packet will send to this router. Then the respective path will be decided and packet ultimately going to. But first of all, so the source machine has to send the packet to this router. So now, if this source machine wants to send a packet to this router, this server, then again, so the packet has to come to this router, then this router will decide, okay, the packet has to deliver to this interface. Similarly, if this machine wants to send a packet to this machine, so again, so the same, so that means the packet has to come to this router is going to forward to this router is going to forward to this interface. That means ultimately, so it doesn't matter, so whether the destination is this, or the destination is this, or the destination is this, always the packet has to come to this router. That's why this is called as a default router. Any packet wants to go outside of my network, I have to always send the packet to my default router. Then the default router will decide, so to whom it is going to send to, so further to communicate correctly or deliver the packet correctly to the final destination. So my job as a host machine, if I want to deliver the packet to someone, so then my job is just to deliver the packet to the default router. Then default router will take its own course of action, so to deliver the packet to the final destination. That is why, so the job of a default router. That's why. So who provides the default router for us? DHCP server. We already know that. DHCP server is very, very important. So we must know, in order to make a communication in the internet, the default router IP address. Without that, I can't able to do. So that's why, so default router is my router to whom I have to send the packet. So which is ultimately using this routing table will decide, so what is the next, so hop or next router the packet will be sent, so that some packet will be reaching at the final destination. So this is the high level overview of how routing works. Okay. Now, once we understood this is what I have already told. So this is written here. So now what I have already told. So this is, if I look into this, so with the help of routing table, how I could able to decide, let's even get a glimpse of it. Okay, we have already told. So every router is going to maintain one routing table. This is the routing table maintained at this. So this router is maintaining the routing table. This router is maintaining a routing table like this. This router is maintaining a routing table like this. Okay. So that means, so looking into this routing table. Okay. Now let's look into here. Okay. So if each and every router is maintaining a routing table, by looking into this routing table, how a router could able to decide? Let's for example, so the IP address of this system is 11.1.1.2, and the IP address of this system is, let's say, 13.1.1.2, and this wants to send a packet to this one. Okay. So now by using the routing table at router R1, how it is deciding, okay, the packet has to be delivered here, not to here, not to here. Let's look into that. So before going to talk about that, you should understood what is the most important information present in a routing table. So let's look into this. Is, I say, most important. So along with this, some other information also maintained. Okay, but so what is the most important information that is maintained? Let's look into that. So a routing table is most importantly have two parts, two information kept inside is, one is a network, then the route. So network is, so when we talk about network, it is written as 11.0 has to keep what is the network ID. Network ID, in this case it is 11.0.0.0, and what is the net mask? In this case it is 255.0.0.0. These are the two important information to make a routing decision is very, very important. Then, so based on this, so you have to decide what is the next hop. Let's say if at this router, let's say one packet is being sent from here. So to, let's say here. In this case, what is going to happen? I do not need to send the packet to the router. Okay. So, but if someone else, let's say मान के चलिए, so let this machine has sent a packet, so to this, ultimately this device, and the packet is already received at the router. When the packet is received at the router, and this packet has to now deliver to this machine, so router is going to deliver it directly to this machine now without routing it. So that's why this is a direct route. A direct route is available. Direct route is available means, so from this router, a direct route is available to this network, because this one interface of the router is attached to this network. But now, let's say, as in our case, my destination IP address is 13.1.1.2. So if it is 13.1.1.2, so based on this subnet mask or net mask, whatever it at this moment, so based on the net mask available in this routing table, I decided the network ID is 13.0.0.0. So now I have to look into, in this routing table at the router R1, when the packet is received, is there any entry exactly matching this network? So 13.0.0.0 with a subnet mask or net mask of 255.0.0.0.0. Yes, there is an entry exist. So now when the packet is being sent from this machine to this router, now router is going to first of all find out what is the network ID of the destination. Based on that, it is going to search whether a entry for that network ID is existing in my routing table or not. If it is, so then the respective route will be find out. What is the route? R3. Route is nothing but the next hop. Okay. So then it is going to find out the route or the next hop, that is R3. So you have to go to this network. What the R1 is going to do? R1 is going to deliver the packet to R3 router. So how it is going to deliver the packet to R3? Then on this interface the packet has to send. Then only it can be able to reach at R3. So that's why this is how a routing table. So I mean a router by using the routing table decides. So when a packet is coming to him, so destined for a particular device. So to which network or to which interface this router is going to deliver the packet based on the routing table available at its own end. Is it clear to everybody how routing table, what are the information, most important information present in the routing table, and how the routing table uses this information to decide, router uses this information to decide which interface the packet is supposed to be delivered to the correct delivery of the packet. Okay, so once we understood this, now the next question comes. So who is going to build this routing table? Someone must be responsible for building this routing table, and we have already told that so there is a routing algorithm. But before that, let me look into another conceptual concept as far as the building of the routing table is concerned. Okay, so let me ask a question. So based on this diagram, previous diagram, let me ask you a question. Okay, here let me just erase this and ask you a question here. Now at this point of time, at the host, at a particular machine, host, let's say this particular machine, so host 2. At this machine, whenever the routing table is going to build up. Okay, so understood the concept, what I have already told, irrespective of the destination. If the destination is this, doesn't matter. If the destination is this, doesn't matter. If the destination is this, doesn't matter. Always the packet has to be sent to this router. Okay, that means the routing table that is going to maintain at routing table, that is going to be maintained at this machine, so is going to follow a static way of building the routing table? Is it better, or should we go for following a dynamic approach to build this routing table as far as the host? So this route is fixed now. If I look into this communication, irrespective of my destination, so this route is fixed, that is always I have to send the packet to this router. So in this case, if I go for a dynamic approach, so dynamic approach is always complex. Okay, but as my route is always fixed, in this case, it is always better to have a static routing table. Na? Yes or no? If I build the routing table statically means, so manually I have to go and make the entry. I already know always my packet has to go to any other network, means it has to deliver to this router. So that's why easily I can build this routing table with the static information available at my end. It is not changing very often. So that's why we should go and so build this routing table using a static approach. So that's why I try to understand. So basically when the routing table is built up, so a routing table is built up either statically or dynamically. Okay, but if I look into at the host, whenever we are going to build up the routing table, so static approach is preferred over dynamic approach as far as the building the routing table at the host end is concerned. But look into the router. If I want to build the routing table at the router, so it may happen, so the destination may be this or this or this. For all these destination, the router is going to so use the same route or different route. I'm joining one more interface from this to this router. Okay, so this router is connected like this. Now, whenever I'm supposed to, this router is supposed to deliver to this. At one time, it may follow this path. At another time, it may follow this path. That means depending on the condition of the network, so that path may be changed. So time to time. So dynamically, the path needs to be changed. It cannot put a fixed path. So that's why at the router end, it's preferable. Dynamic approach is preferable over static approach. Is it understood? Are you getting my point? What I'm trying to say? So at the router end, it is always better to build the routing table using a dynamic approach, whereas the host end, it is always better to have a static routing table as far as the building of the routing table is concerned. So is it understood or a possibility? So that is, so my destination IP address to whom I want to send a packet at the router end can match with 2 or more than 2 entries, but one of them has to be selected based on the building of this routing table and using a routing algorithm. So we are building up the routing table, then deciding to whom to send. But what is the basic goal? So whenever you are designing any routing algorithm, the first and foremost important goal, so to discuss or decide the shortest path. Let's say, for example, if I look into this diagram, okay, so here let's say one machine wants to send a packet to this machine a node A. So these are the nodes of one graph. This is one graph having number of nodes. Each node is representing one host. So now, so whenever I want to send a packet from this host to this host, let's say A to C. Okay, so from A to C, I want to send a packet. In this case, so what are the possible paths available? I may go like this,
or A to B to B to C,
or I may go like this. Okay, if I go like this, look into the cost of going so from A to say 5. If I go like this, look into the cost 1 plus 3, 4. So that means among these two, the shortest path is if I go through B. So while deciding the path to a particular destination, basically the routing algorithm search for the shortest path. That means, so from node A, the routing algorithm will find out what is the least cost of going to B, C, D, and E. To all other nodes from a particular node, so what is the distance, minimum distance, or the shortest path going to all other nodes? So that will be decided by the routing algorithm. So based on that, routing algorithm is going to populate the routing table. Routing table is going to build based on that. So what is the least cost path at this particular point of time? And also the routing algorithm is going to do it dynamically. So that's where the part of metrics, depending on your requirement. Let's say you want a secure communication. You want a network where the communication will be secured. There will be a lot of security in that particular. So whichever path is most secured, let's say you have given a matrix with 1. Bit less secured, you can give a matrix with 2. More, I mean, bit more, so relatively bit more less secured, that is 3. Like this, that matrix you can go and so assign as far as security is concerned. So if you want, so only by distance, then this can be a distance based on the distance. What is the distance between this? So physical device, that also you can give a matrix. So, okay, what we talked about here, that this actually this value depends on the matrix you have decided based on your requirement. Okay, so that's why. So it may be just the example I have given. It may be a security. It can be changed. Let's say for example. So now whenever, let's say, the cost of going from A to C, initially you find it is so 4. This is the list cost based on the matrix. You have given a value 1 year, given a value 3 year. So now going from A to C is 4 at this moment. So you go by this list cost. So now suddenly what happens? This link is broken. Let's say this link is broken. So when this link is broken, so what is going to happen at this moment? So if this link is broken, so now I don't have a path going from A to C via B. So I have to follow this. So in the routing table, so now I have to update. So the current path or cost of going from A to C will be 5, no more be 4. So depending on the link cost, depending on the links available, link cost, so obviously the routing table entry is going to change from time to time. That's why, so as far as the routing at the, routing table, building of the routing table at the route algorithm, you already know there is a very popular algorithm, so that is called Dijkstra's algorithm. So by using which you could able to get the shortest path, so from a particular node to another node. So this is the algorithm is going to be used by the routing table, routing algorithm, to find out the shortest path from one end to the other end. So that is the basic goal of this routing algorithm. Okay. So now, as I have already told you, so the job of the routing algorithm is to populate. I've already told. So there can be one approach. One is static, one is dynamic. I have already told. So that is static is basically used in case of host. That is everybody clear, I think. Okay. If not, you can ask me question here. Okay. And dynamic approach is basically followed by the routers. So router basically follows a dynamic kind of approach to build the routing table, whereas the host machine can use a static, so kind of what? So building the routing table. But when you talk about routing, so it is mostly concerned about the routers. We are not much bothered about the host, because host is having a static so routing table. So that is going to be built by individual so administrator in that network. So but if I look into the network, internet, so then every router is going to build their own routing table. So that is a concern of ours. So that's why we say, so dynamic approach is preferred over static. You can't say that, sir, आप तो बोल रहे हैं host machine में static कर रहा है, आप कैसे बोल रहे हैं dynamic is preferable over static. So from that perspective, we are not telling. So dynamic is preferred over static by looking into the router, we are saying. Because so whenever we talk about routing table, it is mostly concerned with the routers. So that's why dynamic approach is preferred over static approach as far as building the routing table in the router is concerned. This is one approach. Another approach, next approach. It can be centralized, it can be distributed. What I mean to say, centralized, distributed, let's look into this diagram once again. Go back to this diagram once again to understood centralized and so distributed. So look into here, look into diagram. Okay, so now if I look into this diagram, so if it is centralized, what kind of approach you have to follow? That is, if it is a centralized machine, just let me erase this so that. Okay, if it is a centralized kind of approach to building the routing table, so then there will be one dedicated machine may be available in the network. There will be one dedicated machine may be available in the network who is responsible for building the routing table for all. Maybe some, if one is not sufficient, maybe so more than one is distributed across the globe. So they are going to be responsible for building of the routing table. That can be one approach. One dedicated server is so responsible for building the routing table at the routers. Okay, one dedicated machine will be available. So that is one approach. But another approach, every router is responsible for building their own routing table. So that first approach is called as a centralized approach. because one dedicated machine is going to prepare the routing table for all the routers. So, but the second approach we talked about, so that is every router is going to build their own routing table. That is a distributed approach. That is a distributed approach. Can anybody think of just apply your logic, or this server is failed? Let's say this server goes down. As it is a centralized machine, every whole communication goes down. So because if others is not getting, so the routing table from this and this machine is, so let's say some router is requested to get the routing table at its end. So now the server is down. So no routing is going to happen. So the whole communications is down. So if one server, the centralized server goes down, then so distributed is preferable to centralized. This is the reason already you have explained. That is the reason why centralized is not preferred, rather distributed approach is preferred. Now another segregation, how the routing table is built up: local knowledge and global knowledge. Okay, so what is a local knowledge, what is a global knowledge? Let's try to understood. Just let me draw the simple diagram here, so to understood what is local, what is global. Let's say these are the various nodes, how they are connected to each other. Okay, this is A, this is B, this is C, D, E. These are the various nodes, computers connected to each other. Now, so whenever I say A directly connected to B, he must know what is the cost of communication going to be. So A directly connected to C, he must know what is the cost of communication going to C. But A is not directly connected to D. Okay, so he may know initially, he may not know initially what is the cost of going to D. But without knowing the cost of going to D and E, if the routing table built up approach or procedure starts, so that is, so we say routing table built up is with the local knowledge. That means we are trying to build the routing table at A with the local knowledge of what is the cost of going to B, what is the cost of going to C. Without knowing the cost of going to E and D, we are starting the procedure of building up the routing table, and that kind of approach is basically called as a local approach. That means you know the local knowledge. Local knowledge means you have the knowledge of only the neighbors. What is the cost of going to the neighbors? These B and C are the neighbors of A. E and D are not the neighbors of A. So that's why A does not know initially what is the cost of going to E and D, but as these two neighbors, so he knows what is the cost of going to B and C. So that's why with this local information, with this local knowledge, if we start building the routing table at the node A, so that kind of approach is called as building the routing table with the help of local knowledge. But so somehow, kaise karenge that we will discuss later on, but somehow if A collects the information of what is the cost of going to B, C, D, E before starting of any routing table built up, so that kind of approach is called as building the routing table with the global knowledge. So there are two approaches. So building the routing table with the local knowledge, building the routing table with the global knowledge. So these are two approaches, and if I look into the practice, so both are used. So neither, global, non-local, both are in practice in reality. So both approaches are still in use. So what we understood out of it? So what is the approach then that is basically followed as far as building of the routing table is concerned? As we have already discussed, it is dynamic, then it is distributed. Okay, so then either global knowledge or local knowledge. That means dynamic, distributed, global, and that routing algorithm is basically called as a link state routing algorithm. The routing algorithm who follows dynamic approach, distributed approach, and the global knowledge with the global knowledge, build the routing table. That kind of algorithm is called as a link state routing algorithm. But there is another approach, as I have already told. So dynamic, distributed, but with the local knowledge. So whichever algorithm is going to implement the routing algorithm, build the routing table, so that algorithm is basically called as a distance vector routing algorithm. So distance vector routing algorithm uses the local knowledge. So whereas link state routing algorithm is going to use the global knowledge to build up the routing table. This is the basic fundamental we have to understood as far as routing is concerned. One more concept so that we have left out as far as the fundamental is concerned. So that is another concept called autonomous system. Let's try to add what is the use of an autonomous system as far as routing algorithm is concerned or routing a packet is concerned. So let's look into this diagram. So to explain what is the autonomous system. So look into this diagram. If I look into this diagram, I say this is one autonomous system. This is another autonomous system. This is another autonomous system. And when I say autonomous system, inside the autonomous system, there may be several networks. This is one network. This is another network. This is another network. There are several networks combined inside a autonomous system. Then my question is, so what is autonomous system? Why I call this an autonomous system? Let's try to understand like this. So all the networks that is under the control of a single administrative authority, that we basically called as one autonomous system. Let's say, for example, so when you work in the lab, let's say in KIT as an organization. So in the School of Computer Engineering itself, there are several labs. And each lab can be considered as one network. Okay, DL1, DL2, DL3, DL4, ... So all can be considered as one network. But so one machine from one lab can also talk to another machine in another lab, provided the connectivity is there. Okay, but all these machines, if I look into as a whole, they are under the control of KIIT organization. Okay, one administrative authority. There is an ICT cell who is looking into all these machines that is configured across the KIIT University. So that's why KIIT University, all the computers belonging to this university can be considered as one autonomous system. Okay, similarly, so IIT Kharagpur, there are several machines, several networks available across the university. Okay, Kharagpur. So that's why all this can be considered as again another autonomous system. So that means, so that's why we call this. So all the systems that is under the control of a single administrative authority, so they can be fall into one autonomous system. So why you are discussing about this autonomous system? So why it is so important as far as routing is concerned? Let's look into that. Let's say this machine wants to send a packet to this machine. Okay, try to understand like this. This machine wants to send a packet to this machine. Now, so both belongs to the same autonomous system. So that's why. So here, so which kind of routing algorithm which facilitates to make this communication, that is called as intra-ACE. That means it is within the autonomous system. Intra-ACE means within the autonomous system. Intra-college, within the college. Inter-college, from one college to another college. Similarly, intra-ACE, that means within the autonomous system, if I want to make a communication, then the routing algorithm, kind of routing algorithm which is going to help me is called as intra-ACE. So within the autonomous system, intra-ACE routing algorithm helps to carry the packet or send and receive the packet. But if my requirement is to send a packet from here and receive it here, both the packets belong to two different autonomous systems. So that's why intra-ACE, so our routing algorithm not alone is sufficient enough to carry the packet from here to here. That means along with the intra-ACE, we have to add one more routing algorithm that is called inter-ACE. That means combiningly both intra-ACE and inter-ACE routing algorithm is going to make this communication possible from this machine to this machine. Okay, so that means intra-ACE routing algorithm has to run at the internal routers. These are the internal routers, right? So this is not an internal router. Sorry. This is an internal router. This is an internal router. This is an internal router. These two are the border routers. This router and this router are the border routers. Why I say it is a border router? Because this router facilitates to communicate to another autonomous system. This router facilitates to communicate to another autonomous system. So these are the border routers. So remember this concept. So whenever you want to make a communication, so whenever the communication happens within the autonomous system, so then this router comes into picture to carry your packet. So where intra-ACE routing algorithm is sufficient. That means in the internal router, so intra-ACE routing algorithm is sufficient enough to run. But if I look into this border router, in the border router, intra as well as inter, ACE routing algorithm has to run, because so whenever so packet has to deliver to outside, so through this router, inter ACE comes into picture. Whenever the packet has to route inside this, so I mean, so autonomous system, so then intra is going to help. So in the border routers, intra plus inter ACE routing algorithm has to run, whereas in the internal routers, so only intra ACE routing algorithm is going to run to make your communication so possible. Is it clear to everybody, or anybody has any intra or inter? Okay, so abhi abhi jo bole the, so link state, distance vector, these two are nothing but intra ACE routing algorithm. These two algorithms what we discuss right now. So with a global knowledge, with a local knowledge, so distributed dynamic, so local, distributed dynamic, global. So these two are nothing but they fall in the range of intra ACE routing algorithm. They do, these two algorithms only can support to so send a packet within the autonomous systems, not from one autonomous system to another autonomous system. And what is the popular algorithm? So link state jo algorithm bole the, so the popular implementation in the internet is called as the OSPF. OSPF stands for Open Shortest Path First. So this is the implementation of this link state. Link state is the approach, but the real implementation of the link state algorithm is the OSPF, that is the Open Shortest Path First algorithm we used actually in the internet as far as making a communication within the autonomous system is concerned. Similarly, so as far as distance vector approach is concerned, so the real implementation is RIP, that is Routing Information Protocol. Routing Information Protocol, RIP. Okay, so this is the protocol. So these are two intra ACE routing algorithm. But so in order to make an inter ACE routing algorithm, the approach, so that is called as the path vector. Path vector is the approach that is basically used to make a communication in the from one autonomous system to another autonomous system. And in the real time, the implementation is called BGP, that is the Border Gateway Protocol.
Border Gateway Protocol.
Yes, Border Gateway Protocol. Okay, so this is the overview of how internet, so routing works and what are the various routing algorithms. And so for making a communication, why we need a combination of intra and inter ACE routing algorithm. So ultimately in the internet to make the communication possible.